Hello friends, welcome again. So till now we have discussed about the different 3D printing processes. This particular session that I will be focusing right now will be another domain, which is basically the hybridization of additive as well as subtractive manufacturing processes. Till now what we have learned about the use of the 3D printing using polymer based, metal based, ceramic based material, but we have not clubbed actually the subtractive manufacturing as well as the additive manufacturing part. So that is the additive and the conventional manufacturing part. So this will be really a wonderful study. So what we are interested is to develop a component like this. This is basically a hip implant, a very common implant that is being used by a number of orthopedicians. So what we have done is we prepared the master using polymer 3D printing, and this particular part, as per the requirement of the different patients, CAD file were generated using the CT scan. Then the actual 3D printed on a polymer printer. The component was prepared in the 3D form. Now, in a typical casting environment, as you know, we have a pouring basin, then down sprue, then the connecting runners, and on this pouring basin we have attached these components. So depending upon the volume of the component, we can attach 2, 3, 4. But since this is a customized solution, so normally people prefer to add 2 to 3 maximum, right? So different geometries that has been selected, so it has been attached for the typical casting application. Then we put a slurry layer around this. So for putting the slurry layer, put a molten wax pattern around this, and then for the component, after the development of the slurry layer, it is put like this. Now the polymer that we used over here, like in this case, this was the ABS. It comes out at the temperature of around 1000 to 1100 degrees Celsius, and at that stage it comes into the gaseous stage, right? So it is easy to remove that. But if I'm using in place of polymer the whole wax pattern, this can be removed at much lower temperature, that is around 200 to 50, which is quite a commercial practice nowadays for different investment casting application. So what we have done is we removed that part, and finally we put the molten metal into it, and these are the type of castings, final the cast component that has been prepared. Now the thing is, I can customize it for particular patient, and for the cost effectiveness, for reducing the cost of the component, it has been hybridized. So hybridization is for the casting process as well as for the 3D printing process. And then the IT grade that I am getting for the assembly is to the tune of 9 to 10, which is really good for the assembly, right? Some morphological analysis in terms of the microstructure that has been done, and what we have tried to investigate in this case, which definitely we will see in detail in our coming sessions, how to control the microstructure, how to control the grain fineness number, how to control the porosity and correlate with the different ASTM codes. So I believe this information is really useful, and with this the overview of my 3D printing and the hybridization with different processes application, this part is over. In our next week session, we will be taking now specifically to a particular printing technology and all the details for that processes only. So week 3 will be mainly focused on the polymer, followed by gel, followed by metal, and the different sensor and case studies application. I hope you enjoyed this. Thank you very much, and keep watching.